Hello everyone. So in this video, we'll see the Spring Boot application to connect to vector database, and using the Spring AI library, we'll also use the Java client Maven library to connect to the vector database. And the vector database itself is been built using the Spring Boot framework. And we'll see the examples, and I'll also share the link for the Spring Boot application as well as the Maven library, that is a Java client, as well as the vector database which has been created using the Spring Boot framework. All the GitHub three links I will share for the GitHub. You can even fork, you can use, or you can freely change and use it as per your purpose. So let's get started. Now let us first understand what exactly the vector database in a brief, though it is a very large concept, but in short, a vector database is essentially a specialized database that stores and manages the vector embeddings, which are a numerical representation of a data like text or images or audio or maybe a video in a multidimensional space. So think of it in this way, like first data, which is like a text, is converted into a vectors or maybe a list of numbers using the embedding models. So these vectors capture the semantic meaning, like similar items will have a similar vector representation. So the vector database then stores these vectors and provide an efficient way to search through them. For example, if you have the sentences like I love dogs, I like puppies, the stock market is crashed. So when converted into vectors, the first two would be mathematically closest, that is I love dogs and I love puppies, to each other than the third one because they have a similar meanings. So the key features that make the vector database special is like efficient similarity search. Most probably it is an cosine similarity search, finding the closest vectors. It is optimized for high dimensional data, specialized in indexing methods for fast retrieval, and its ability to handle the large scale vector operations. So there are popular databases, vector databases, which includes like Pinecone, Viviet, Milvus, Quadrant, and ChromaDB. Um, but in our case, we will have our own database, that is Similec, which again I will share the GitHub link. You just need to use the Docker, and which has a pretty much a basic similar functionality, which we have discussed, like Pinecone, Viviet, Milvus, Quadrant, and ChromaDB. And you can start and leverage, or you can use it for your own purpose. Now that we understood the vector, what is vector database, how it works, we need to understand the RAG, that is a retrieval augmented generation. We'll see a very brief introduction, and then we'll move towards the example. So RAG, that is a retrieval augmented generation, is a technique that enhance the large language model, that is LLM, by combining them with a retrieval system that pulls the relevant information from the knowledge base before generating the response. So knowledge base is a vector database. So how basically the RAG works? So first of all is an information storage, that layer or documentation or data converted into the vector embeddings that we have seen, and it means the embeddings are stored into the vector database, and this becomes the knowledge base. So here is a diagram where, as we said, that information storage in form of the vector database. So business specific information and documentation in terms of the embeddings. Then we have the next one is the query process. So when user asks the questions in the application, that the query is converted to a vector, and the system searches for the vector database for the relevant information. And here in our case, to connect to the vector database, we have Maven library. So the system searches for the vector database for relevant information, and the most similar or relevant information content is retrieved. We'll see the example, a practical example. uh, then we have the generation, that is a third part using the reg. So retrieved information is sent back to LLM along with the user question, and the LLM uses the context to generate the information informed response, and this helps to ensure answer are accurate and grounded with your data. So basically, the benefits of RAG is it reduces the hallucination since the responses are based on the retrieved facts. Uh, Keeps knowledge current without restraining the model. RAG allows a domain specific knowledge injections, like in a traditional LLM. We have a general response like OpenAI, Cloud, Gemini, or Mistral. They do not have business specific information. So using the RAG, we combine the vector database as well, vector database embeddings, and the OpenAI or Cloud or Gemini or Mistral kind of LLM, and combined together we get the response, and we send back the response. So if you see the real world examples, that customer support chatbot that access the company documentation, another is a legal assistant that references the case law, a research tool that can analyze the scientific papers, or enterprise search system that understand the context. So let's see the example now. Thing that will go to the GitHub URL. This is my GitHub URL 913165, and here you can search for the Simulink, or you can go to the repository and you can just seek for the similar. So Simulink is basically a basic vector database implementation, and it uses the Spring Boot, and it has also a Docker file. You can see the README file, and it's a simple REST API, so it's very easy. You can use even this without using a client, but I have made a Java client for now. In future, I am planning to make the Python as well as the other client over there. So to run this the Simulink is just a Docker command which is also been specified in this README file. So I'll just copy and make sure that either if you are using the Windows, you have a Docker desktop, or if you are using the Unix system, then you need to install the Docker and you need to start the Docker engine. So in my case, Docker is running and I have a Docker desktop. So what I'll do is simply go to this terminal, or you can go to this CMD. So let's check first of all Docker is running or not. So Docker version, if I say, so it's showing the Docker is Docker daemon is running. Okay. So first of all I clear it and I just paste this. So Docker run -p, that is a port, a container port, and outside port 6767, and then this is a simple this is my URL, Docker Hub URL, and /Simulink. And also source code is also available in the GitHub, so you can play with it. And if it is showing the started, so our vector database is running. All right. Now open the Postman, and if you do not have Postman, then you can download and install and just sign up with the Postman. So, and I'll also share the URL and the body of this API. So I have the Postman URL available, and it's very simple. Again, let me show. So here the first, because your vector database is running, so first and foremost thing that you need to do is you need to add the vector store. So there are different vector stores that you can add for your business purpose. So here I'm just giving the simple name vector underscore store, and the URL is http localhost 6767. And if you have another IP where you are installing this vector, running the vector database, then you can have the IP address, and the port number is 6767. And the first one is a collections. So a vector store collection is nothing but it's a collection of various vector stores, 1 2 3 4 5, and any vector store that you would like to give the name. And the body part is a size. So basically the normal size is a 15 this is 1536 dimensions. And the distance that we are going to use is a cosine similarity, so cosine distance, and the pulse is equal to true. So you can have a pulse is equal to false or true. False in the sense that if you want a high performer, that you can use the false, and then the whole vector store will be stored in the memory. But in that case, you will get the performance, but the moment you restart the vector store, then you will lose the data. So better, I would go for this persist equal to true. Okay, all right. So now our vector store is running. So I'll just uh, click on this send button so that a vector store can be created. So after clicking on the send button, the created and persisted collection successfully. And so this is the URL and the body part, and it's a post method. And you have also a delete vector store where you have just have the same URL, and you will have the delete method. If you want to store into collections, then you can have as I say that in memory, then you can have this false. Now I'll just click on this get all collections. So URL is a collections and you have a method called get. So I'll just click and see. So currently we have one vector store with these properties. Okay. And currently we do not have any sort of a points that we have loaded. So it is showing there's a blank array. So we'll use this Spring Boot application to store all the points over here. All right, so there are lots of different methods. I'll export and I'll save into the GitHub URL. All right, now we have completed creating the vector store. What we can do is simply go to this under my GitHub page, uh, and in the repository, you can just have a Spring Boot Simulink client, or either you can directly use the REST API. But for the sake of if you want to use the Spring AI, then perhaps you will have to download and create a Maven library. I'll show you how you can create. So just go to this Simulate client and clone it, and then I'll show you how you can do it, uh, the Maven package. So I have cloned into the IntelliJ. You can just have uh, a file and new, here a file new, and a project from the version control, and you can put this URL and then you will get like this. Okay, or either if you are using the community edition, then you can clone it on a local and you can open using the file open. So if you go to this Maven, and here there is a version called 0.0.2 snapshot, and you got to go to Maven, and you can have for the time you can just click on the install, and this Maven library will be stored in your local M2 repository. If you face any sort of a difficulty, then you can just use the skip test and then again try the install over here. All right, so this is a simple Spring AI client, and you can go through this source code. It's a very uh, I use for the compatibility of the Spring AI. As currently it is not by default included in the Spring AI, so you can just build and you can have a local repository for the same. All right. So once you are done with the Simulate client Spring Boot, and you can go to this repository, and now you can have the real Spring Boot application that is using the Spring AI. So this is also I have published into the GitHub repository. You can take this Simulate example 001 and you can clone it. I already cloned on my local, so I'll just open this other Spring Boot application. So I'll walk you through the same. So you have an app config where you have this property, okay, and then you have this app config which has an environment. This is a very simple Spring AI application that if you are using, it's very simple. Again, so first you will declare this Simulink vector store, and you are passing this embedding. And here if you are saying that embedding can be so first what you get it the you need either any of those open LLM, that is or any LLM that like OpenAI or Cloudy. In my case it is a Mistral AI. So you can have the vector store and you use the Simulink vector store, which is also used by passing the embedding model. So embedding model is this in my case is a Mistral AI. And how you can configure here in the add configuration, here if you see this environment variable, and here you can Spring AI Mistral AI API key. So you just need to have the key. If you are using the OpenAI, you can use the OpenAI key. Any AI key API AI key you can use. So you can have an environment variable. Then um, then you are initializing the property. In my case it is a simple one. You can again refer to this example, which is a very similar typical string AI example. Then you go to this property file. If you say application.property, so in the Simulink we have the prefix Spring AI vector store and Simulink. Then you have the host is nothing but where your vector store is running. So either you can replace this, in our case it is a local host, so I just put as a local host. In your case, if you are running on a IP any machine, then you can use the IP address. Then the port, the collection name. If you remember that we have used this collection store is a vector store name. The schema initialize that whether you want the application to initialize the schema, or in our case currently we already created the vector store, so we are just putting as a false. But in your case, if you want to create a vector store from the Spring AI application, then you can use it. Dimension, yes, 1536. Similarity distance, it is a cosine. And the API key, in my case, it is currently no API keys because it's a simple application and I'm showing as a POC. In future, I'll put this as well so that, or you can also change the code and you can have your own API key and you can start with it. But I'll keep for now as an optional. All right. Then you can have a simple controller, which is nothing but the load data, and then you have the search. Simple. In case of the load data, you just load your application data or business data. So what in for a sample application, I just using this 50 load data. It has a smartphone, it has a company name, and it has a description. So smartphone, then laptop, a tablet, smartphone, a tablet again, and again the brand is Lenovo, Google, Samsung, Apple, Asus, HP. These are then I'm loading this 50 product, and then I'll show that we can have the similarity search. So control through the controller you are loading this data, and in case of the service, if you see this example has a load data and the search functionality. So let data again using the resource. This is a typical Spring Boot application. So you are just using the load data and then you are using the text splitter, and then you are getting the embeddings from the LLM, and then you are storing into the vector database. Okay. So here if you see the vector store dot add, this will splitted document, it will store into the vector database in form of the embeddings. And so now in case of search, so when you are searching for your documents related to the business database, using this is all using the RAG, and you are just calling this vector store dot to similarity search, and you're passing your query. So I'll show you the examples over here. All right, so now let's run this application. So the application gets started. So I'll go to the postman and I'll just use this load document. It's a very simple again, a get URL, and you just call this load data. So let's check the URL uh, in the controller, and it is a simple load data. Okay, so let me click on this send button, and if we go to this here, you can see the logs and it is loading the data. So let's wait for some time. So now go to the postman and you can see that data loaded successfully. How can verify? So get all collection, if I go, so get all the payloads, and if you see this localhost collections and vector store, then payloads, and we can see all the embeddings are there. Okay, now we'll go to this similarity search, and what I'll do, I simply put as a body, and in the param I'm just asking for this laptop, and I put a filter, and if you see the by default top similarity search will come. So let's click on this search, and you can see the top three came here, and the laptop, it contains the laptop. All right, here you can see that laptop, and we can see the first two one is very much similar to laptop. It's a powerful processor. So here currently we are getting the all the products related to the Apple. So what I will do is simply if you go to this example, and here I specifically filtered the Apple. So if I do the, you can also have a filter that you want only related to the Samsung, and if I restart the application, because we already have loaded the uh, all the data. So what I can do is simply if I search for here the laptop, and then it will go for the Samsungs or related to Samsung, and the first one it should be related to the query. And here you can have the top result. So top key result, if I say I just want a top two result only, and if I restart the application and if I check it, I'll get the top two result as well. So if I again search for that and I get the top two, okay. And if I remove this filter, the last filter, and say for example, here if I say okay, and so if you want to remove, you can just simply comment it, and you can have this one, okay. And if I remove this all the brands and filter, and if I run the application again, then if I try the searching for the laptop, then I can get a various brand, even Apple, then the HP. You can see that's ultrabook, which is very much similar to laptop. It is not providing the laptop itself direct word, but it is very similarity. So this is a similarity. So it's a perfectly running, and I have tested it on at least 10,000 data from the business, and that's a sufficient any document that you can put, and you can load it using the split and this vector database. All right, so that's a pretty much a demo of how a similar Simulink vector database, which is being built using the Spring Boot. Again, you can please in the GitHub repository, if you go and just fork it, go through the whole application. I already given some of the pretty much basic documented how you can use the curl, and then you can change, you can use, you can leverage, you can even contribute. I will be helpful, and you can fork it. All right, so that's it for this video. Thanks for watching. See you in the next video.